Okay, here we're going to be using the global metrics that we have found to get the local metrics. What that I mean is we're going to use the stiffness of member in global axis to get the stiffness of member in local axis. So this Kn is actually equals to this. We're going to be getting this using this. Okay, so let me just at first quickly erase all these lines that I've just drawn. Okay, now I'm going to start the work. Now remember that sine theta is equals to 0 when the value of theta is 0 degrees and cos 0 degrees is equals to 1. So when the member is in local axis, this is the member, this is the AB member, and when this member is in local axis, the theta value is going to be 0 degrees. Right? The theta value is going to be 0 degrees. C here stands for cos theta, S stands for sine theta. So sine theta is 0 and cos theta is 1. In this case, when theta is equals to 0 when it is in local axis. That means this value is going to be 1, this value is going to be 0, this value is going to be negative 1, this value is going to be 0, this value is going to be 1, sorry, this value is going to be 0 because there's S, the value is going to be 0, this value is going to be 0, this value is going to be 0, here this value is going to be negative 1, this value is going to be 0, this value is going to be positive 1, this value is going to be 0, this value is going to be 0, this 0, this is 0, this is 0. So this is, we have this right over here. How can we have this? You can say that this is 1, this isn't Sx, but here you can see that the entire matrix is multiplied by Sx. Meaning when Sx is multiplied by 1, it is going to be Sx. When Sx is multiplied by negative 1, it is going to be negative Sx. And whenever there is 0, Sx multiplied by 0 is 0. So if you look at this, we're going to get this, right? So let's do another line while I'm multiplying the Sx. Here 1 Sx is Sx, 0 Sx is 0, negative 1 Sx is negative Sx, 0 is 0, then 0, 0, 0, 0, and negative 1 Sx is negative Sx, and we have 0, then 1 into Sx is Sx, and 0 is 0 again, 0, 0, 0, 0. So right here you can see that this matrix is the splitting image of this matrix. So we can use the global axis stiffness always for truss members. Even if it is in local axis, we do not need to use this. We just need to make sure that if it is local axis, the value of theta is going to be 0 degrees, and we're going to get the same results from this as we have gotten the same results from using this. Okay, so that is it for this video. Thank you very much for watching.